This video is going to cover atomic structure for GCSE chemistry. Now, what I've started off here is I've got an atom labelled up in the centre. We've got our two key parts to our atom. So in the middle, you will find the nucleus of the atom, and then surrounding that nucleus, you're going to find shells of electrons. So there's some really important parts to the atom. Now, this little table here is something you're going to need to be able to fill in for a GCSE exam. It will probably be one of the first questions that you'll get on the paper. So the key things that you'll need to know about are the masses of the protons, the neutrons and the electrons, and their charges as well. Now this is really simple to do. So in the nucleus is where you find most of the mass, and this is where you find the protons and the neutrons. And what we say, the relative mass of a proton is 1, and the relative mass of a neutron is also 1. Now the reason why we use the term relative mass is because the size of the mass of the protons and the neutrons is so small, it's not really worth us writing them out every single time, and it's a lot easier if we just give it an arbitrary unit of 1. So I've got here, the mass of a proton is 1.67 times 10 to the minus 23. So that is a very small number. Now, I've drawn this out here with all the zeros so that you can see exactly what the mass of a proton would be like in one long number. So you can see that there is a 0 here, and look at all these zeros. This is an absolutely tiny number of kilograms. So the mass of a proton is so small. What we do, instead of writing this big number out, this tiny number out every single time, we set the standard is that a proton has a mass of 1. Now, we've also given the mass of a neutron here 1 as well, because relative to each other, they have the same mass. So a neutron weighs the same. This absolutely tiny number weighs the same as a proton. The other unit that you need to know is for an electron. So the size of an electron is very small, and an electron, relatively, is 1/2000th of the size of a proton and a neutron. So the mass that we use, the relative mass of an electron, is 5 times 10 to the minus 5, 1/2000, or 0.00005. I hope I said that right. So 0.00005. So this is not the actual mass of an electron. The mass of an electron is 1/2000th. So this divided by 2000. That would be the mass of the actual mass of an electron, but we use 1/2000 because we're using the relative mass, a 2000th of the relative mass of a proton and a neutron. So we could also say that this number here is so small that it is basically 0. Because the mass of an electron is so small, we can basically say that it's 0. It's so small we don't really need to count it in the masses of our atoms when we're going to do our calculations later on. Now, the other key things that you need to know about the protons and the neutrons and the electrons are really important. So the first one is the charge of a proton. So the charge of a proton is +1. The charge of a neutron, and it says it in its name, is neutral. 0 has no charge at all. The charge of an electron is -1. So we've looked at the different particles that make up an atom. Now we can start to look at what kind of charge an atom is going to have. Now we're going to need a periodic table to help us out with this. So what we need to do is we need to be able to explain why atoms overall have no charge. So because we've got protons with 1+ charge, we've got neutrons with no charge, and we've got electrons with minus charge. Now it's quite simple to work this out. So we'll just pick a couple of examples to explain this. So carbon is a good place to start. So a carbon atom, it has an atomic mass of 12. That's because it has 6 protons and 6 neutrons. So an atom of carbon has 6 protons in the nucleus, it has 6 neutrons in the nucleus, so its overall mass is 12. Now for all atoms, they are always neutral because they have the same number of protons as they do electrons. So the atomic number will tell you the number of protons an atom has, and it will tell you the number of electrons an atom has. Now it's really important that we're referring to atoms here, because later on in the course we'll look at ions when the atomic number will not be the same as the number of electrons. But for our first example here, we've got 6 protons for a carbon atom, So in the nucleus, that charge in the nucleus is 6+. Now surrounding the nucleus, orbiting in the shells, are all the electrons. And because there are 6 electrons with the opposite charge of a proton, there are 6 minus charges. That gives us 0 charge overall for the atom, because there's the same number of protons as there are electrons. Now the next thing to look at for atomic structure is the number of electrons that you actually find in these shells. So what we've said so far is that in the nucleus we find most of the mass of the atom, because in the nucleus you find the protons and the neutrons. Surrounding that nucleus we find the electrons orbiting in shells. Now the key thing that you need to know is how many electrons that you can get into each shell. So in this little table here, the first shell can hold a maximum of 2 electrons. The second shell has a maximum of 8 electrons. The third shell, a maximum of 8 electrons. Now I've written the fourth shell in black because for GCSE what we do is we stop at calcium, and the most electrons that you will have in that fourth shell are going to be 2, for 2 in the outer shell of a calcium atom. So if we've got one shell, this first shell is going to have a maximum of 2 electrons. The next shell will have a maximum of 8 electrons. The next shell will have a maximum of 8 electrons. And then our outer shell, if we're drawing to calcium, will have 2 electrons in the outer shell. Now we've looked at how to work out the number of electrons an atom has. So if we look at boron, for example, 5 protons, 5 electrons. And we've also looked at the total number of electrons that you can get in each shell, so the maximum number of electrons in each shell. We can now go about drawing some different atoms. So to remember, we have 2 electrons in the first, 8 in the next, 8 in the third, 2 in the outer shell. So you will go about this by filling up the first shell first. You then can move on. So once you put 2 electrons in the first shell, you can put 8 electrons in the second shell. That will be full. Then you go on to the third shell and so on. So let's have a look at drawing this is for different atoms. So we'll start off with a nice simple example here, and we're going to start off with hydrogen. So if we look at the periodic table, we can see that hydrogen has 1 proton, it has no neutrons, so it has a mass of 1, but the key thing here is the atomic number, which is 1, which means it has 1 electron as well as proton. Now if we looked at our table, we can get a maximum of 2 electrons in the first shell, but we don't need to fill it. We only need to put 1 electron in that first shell, because hydrogen has 1 electron, and that's it. That's as simple as that. That's the first shell drawn for hydrogen. Our next example is going to be beryllium. So here is a beryllium atom. Now beryllium has got 4 protons, it's got 5 neutrons, so it has a mass of 9, but the key thing again, the 4 protons, which you get from the periodic table, that means there's 4 electrons because it's a neutral atom, so we'll have to fill up the first shell of 2 electrons. 1, 2. Then we're going to need to move on to the second shell, and because there are 4 electrons in total, this next shell has 2 electrons. So we've got 2 electrons in the first shell, and we've got 2 electrons in the outer shell for beryllium. For our next example, we're going to look at a slightly larger atom, so we're going to look at aluminium this time. So for aluminium, the atomic number is 13, so there are 13 protons for an atom of aluminium. So looking at the number of electrons in each shell, there are 13, we're going to need 2 electrons in the first shell, 8 electrons in the next shell, and then 3 electrons in the outer shell, so that adds up to 13. So that's 2, 10, 11, 12, 13 electrons for aluminium. Just to review, it's got 13 protons, 13 electrons, so there's no charge for that aluminium atom. My fourth example is looking at sulfur. So this time sulfur has 16 protons in the nucleus. It has 16 electrons therefore. So the first shell will be 2 electrons. The next shell will be full with 8 electrons. and then the outer shell is going to have 6 electrons. 1, 2, 3, 4, 5, 6. So counting them carefully, we've got 6 electrons in the outer shell of sulfur. So that's 16 electrons in total. So again, 16 protons surrounded by 16 electrons, 0 charge overall for a sulfur atom. Now, beyond just telling you the number of protons, neutrons and electron an atom has, the periodic table has got another couple of useful features. Now, the two features are the rows, so we've got the periods, which are the rows, and the columns, which are the groups. Now, these are incredibly useful. This is because these numbers tell you a little bit more about the structure of atoms. So if I go and look at beryllium again as an example, so we start off looking at beryllium. I'll just put it here, I'm going to cover up some of the periodic table here. If we look at beryllium, we've found that we have 4 electrons in beryllium just from looking at the fact that there's an atomic number of 4, so there's 4 electrons, 1, 2, 3, 4 electrons for beryllium. But there's another really cool thing about the periodic table that's really useful. So, the period, which is the row, that tells you how many electron shells an atom is going to have. So, beryllium is in row 2 of the periodic table, so it's got 2 shells. The group number tells you how many electrons you're going to find in the outer shell. So for this one, beryllium is in group 2, so that's the 2 electrons in the outer shell for beryllium. We'll have a look at our other examples as well. So if we just look at hydrogen, hydrogen is in period 1, row 1 with helium. Sometimes you'll find it written here in group 1, just above these ones. It's not a metal, that's why it doesn't really belong to the group 1 elements, but it does have 1 electron in the outer shell, so sometimes it will be written with group 1. So it's got 1 electron in the outer shell and 1 shell because it's in period 1. Our next example, let's have a look at aluminium. So if we have a look at aluminium here, we can see, if we just predict, we know that it's going to have 13 protons and 13 electrons. We know it's in row 1, 2, 3, so it's in period 3 of the periodic table. It's in group 3, so for the fact that it's in period 3, means we should predict that it's going to have 3 shells, which it does, 1, 2, 3. It's in group 3, so it should have 3 electrons in the outer shell, 1, 2, 3, and it does. If we have a look at sulfur, we'll find the exact same thing. If we find sulfur here in the periodic table, it's got 16 protons, 16 electrons, that's absolutely fine, so we know the number of electrons. We know that it's in period 3, it's in row 3 of the periodic table, so we should predict it has 3 shells, 1, 2, 3, and it does. And because it's in group 6, we should predict that it should have 6 electrons in the outer shell, 1, 2, 3, 4, 5, 6. So it's really, really useful for the elements that you find in groups 1, 2, 3, 4, 5, 6, 7, and 8 as well. So sometimes it's written as group 0 here, sometimes it's written as group 8. So it's really, really useful for knowing these grouped elements for being able to draw their atomic structure. So for GCSE, you won't have to draw anything beyond calcium, so not knowing a group number for these is not really that important at GCSE. You will learn if you do A-level that these have some slightly different characteristics and some slightly different structures, which is why they don't ask you to draw them at GCSE. So I hope that video has been really useful for you as an introduction into atomic structure. The next thing to be looking at will be how atoms, they go off and form ions and how they actually stabilize themselves. But go back, watch this video, have a look back through all these different structures, stop it, pause it, try and write out the structures if you're not quite sure. You must make sure that you learn these basic charges from the beginning. So you must learn this. You must know the charges of the protons, the neutrons and the electrons. You've got to learn the masses here. If you don't do that, you're going to find it very, very difficult to work out the structures of atoms properly. You don't have to learn the periodic table off by heart. That will be given to you in an exam. But it's definitely worth you learning about the groups and the periods of the periodic table, because that will also really help you with drawing your structures of atoms. So again, I hope that's been really useful. Thank you very much for watching. Please like this video if you really enjoyed it. subscribe to the channel, and be really, really great if you could share these videos as well.